Oh my God, have I been muted this whole time? Oh God. If it gets skinnier, if there's a fraction in the front. I think I just was muted this whole time on Zoom. So I may have to remake this video. So I'll watch later and we'll see if I can use this. God, guys, today's just been a day. And it's 10, 11 a.m. Anybody else feel that? Or is that a personal problem? Okay. Okay, it's a group problem? Okay. Sometimes it's just a Miss White problem and I have to deal with that. But like, man, I just like cannot win with technology. And I had kids NWA testing and I've got you testing and I've got online kids testing. I just like cannot get it together. I feel like I'm on like a hamster wheel. Like I'm working really hard and I'm not going anywhere. Anybody else? Okay. That's Miss White's rant for today. Let's move on and do some problems. 6 more minutes, so I don't want to waste your time. Okay, this first one, what shape is this or what's the name of the parent function? Absolute value, good. And we know what shape that's going to be? A V, good. Let me make a little darker color so we can see it. Please erase, thank you. It's an absolute value. It's going to be a V. Where does it normally go through on my axis? Like if I just drew a normal absolute value, where does it go through? 0, 0. So it normally is here. I'll draw that in like a lighter color. So it normally looks like this, right? If I do the +1, that moves it left or right. Since it's positive, it's opposite of what we think. So it's going to go left 1 unit. So I'm just literally going to scooch it over 1 unit and I'm going to draw a V over here. You can make out the points nicely if you want. I just want the general shape. That's why we learn parent functions. I don't need all the exact points. I don't need a t-table every time you do this, but like I need to see that it looks like that. You don't need the first graph, like you only need the second one. So if you don't want to draw that one, you don't have to, but I think it's sometimes cool to see like how we got to where we need to get. All right, let's do another one. This next one says x minus 2 squared. So what function is that going to be? Squaring function, it's going to look like a parabola. When I did this on my own, I did like a sketch off to the side. Feel free to do that or feel free not to. It's your notes. What does a normal parabola or squaring function look like? U, and it goes through what? The origin. Good. So it goes here and it looks like a U. Something like that. This time though, I'm doing minus x minus 2 squared. Since it's minus 2 on the inside, it's going to go left or right. And it's going to go right because it's opposite of what we think. Right 2 units. 1, 2. So it's going to go here. I'm going to draw my U function here. The squared is what makes it look like the shape. That's why we work. That's the only thing that we worry about it with. All right, next one. This one says ln of x minus 2. What's ln of x? What's that parent function? Natural log. And what does that look like? It's like a little curve, right? It looks like it normally goes through the point 1, 0 right here. And it looks like this. Now we're going to do a whole unit on logs and exponentials, but logs and exponential functions are inverses of each other. And so like the exponential one goes through 0, 1, and it looks like this. So this is, they're symmetrical about the line y equals x. So that's kind of a cool thing. We just flip it. Jared, did you have your hand up? Nothing. I'm just making a math point. Sometimes I just make math points. What I'm going to do now, though, is I need to move it down 2 units, right? That minus 2 at the end means that it's going down. There are no parentheses there. That's how I knew that it wasn't on the inside. It's not a C, it's a D. It's on the outside. It's not inside the parentheses with the X, it's on the outside. So it's moving down 2. I messed up my color scheme, whatever. This one will be in red. If I go down 2 units, that doesn't mean that I'm going to be on the y-axis. It means that I'm going to be at the point 1, negative 2. And I'm going to do one of these guys. I didn't draw my purple graph exactly, or else it would be over a little bit more, but that's okay. Like that maybe. Okay, so we're just moving up and down, left and right. The next one, though, has something different. It's got a negative out front. Do you know what a negative does in the front of a graph? I'm going to flip it. My normal reciprocal graph has asymptotes here. And my normal reciprocal graph starts low in that like third quadrant and then ends high in that first quadrant. So this is a normal 1/x. Its negative is going to be flipped quadrants. That's going to look the same. Flip the quadrants. So instead of being in the third quadrant, it's going to be in the second quadrant. It just flipped up here. And instead of being in the first quadrant, it's going to flip down here to be in the fourth quadrant. So I'm going to erase the red one. This is what that would be. Okay. So what I need you to do, I'm not assigning any more homework. You should have turned in one days ago and 1 2 today. You need to do the BFF graphs. That is due on Tuesday. If you need any help with that over the weekend, let me know. Or if you need any help with that on Monday, let me know. But I'm, the key is already online, but if I make a video, I'll put it on YouTube and put a link on Schoology. We need to get more of this into 1-3. And I forgot to tell my other class, but I will update Schoology. I'm trying to get all of through the rest of the quarter updated. We're going to have another test on 1-1 through 1-4. We're not going to finish all of chapter 1. I'm hoping at least 2 more quizzes before the end of the quarter as well. Okay, that's kind of where we're at.
Can you go back to the last problem?
No, the reciprocal one?
Yeah, so you said, like, before you did that, like, you were like, can you just draw it?
The normal one?
Yeah, the normal one.
Yeah.
You said, what'd you say? It was like,
I said they're asymptotes.
This one ends high, and then this one, like,
yep,
ends low or something, but I thought we read graphs left and right. You know what I mean?
Yes. Okay. So when I read this graph, it's starting, I think what I meant was like it starts in like the negative quadrant,
Okay.
and then it's ending in this positive quadrant.
Okay.
Technically, it's ending at 0.
Yeah.
And this one's ending at 0 and starting at 0.
Do they ever touch 0?
They will never
Okay,
touch any zeros. No.
Same thing with the natural logarithm one?
The natural logarithm will never touch this axis.
Yeah.
Okay. Yeah. Yes. And as we get more into asymptotes, those are asymptotes that we'll see. Let me stop recording.